This will be for the Kuta software worksheet, radicals and rational exponents. All right, so in the first section, they want us to write each expression in radical form. So what does that mean? Well, x, the base number that's being raised to a certain power here, that is going to be underneath the radical symbol. Okay, and the root number is going to be right outside of that radical symbol. And the exponent, if you put that whole thing in parentheses, the exponent will be right outside the parentheses. All right, so right here we have 7 raised to the power of 1/2. Now for the exponent itself, you want to remember that the numerator is going to be the exponent. All right, so the numerator is the exponent and the denominator is going to be the root. All right, so let's look at number 1. This right here, 7, that's the base number because it's being raised to an exponent. So we keep the 7. Okay, and we said in the write-up that number is going to go underneath the radical. All right, so the 7 is going to go underneath the radical. Okay, and we said the denominator is the root, and at the beginning we said the root would be right outside to the left of the radical. Okay, so the denominator is the root, and that's just a 2. And we said the numerator is the exponent. Okay, so the exponent goes right there outside the parentheses. All right, so now we're not quite finished yet, and I'll explain 2 things briefly. Okay, for one thing, if it's the second root, like we just had in our problem, if it's the second root of, say, a number x, that's just the square root. Okay, so you don't need the 2 for square root, it's just radical x. All right, so that's one thing I wanted to mention. And the other thing, most of you already know this, if you have a number x and that's raised to the power of 1, the exponent is 1, that really does nothing. So x to the power of 1 is just x. All right, so if the root is 2, you don't even need to write it. And if the exponent is 1, you don't even need to write it either. Okay, so right here, the root is 2, so we don't need to write it. So it's basically the square root of 7, and it's to the first power, but that does nothing. We don't need to write that either. So that's the final answer right there. It's just the square root of 7. So when you have a number raised to the power of 1/2, it's just the square root of that number. All right, let's look at number 3. So we said at the beginning, we keep the base number, so we keep the 2, and we put that under the radical symbol. Okay, we said the numerator is going to be the exponent, and we said the denominator is going to be the root. Okay, so it's the third root of 2, so right here, the third root of 2, and we put parentheses around it, and the exponent is going to be to the power of 5. So that's it right there. All right, so try number 4, please. All right, let's see. We have our base number 7, and that's going to go under the radical symbol. Okay, we said the numerator is the exponent, and we said the denominator is the root. Okay, so it's going to be the third root of 7. Use parentheses, and then the exponent is to the 4th power. That's it. Pretty simple. All right, next section, write each expression in exponential form. So what does that mean? All right, so basically it's the same as the above, except we're working backwards. So it's going to be in the form of x to the power of a over b, where a, the numerator, is the exponent and b is the root. Okay, so it's the same thing like we just did, except now we're working backwards. We're going the other way to exponential form. In the first case, it was radical form, and now it's exponential. All right, number 7. So we said at the beginning, when it's a square root with no number, the number is automatically 2, right? We said that at the beginning. When there's no number for the outside the radical to the left, that's automatically a 2. That's the square root. All right, so you can put a 2 right here if you like. All right, and we said that the exponent is going to be the numerator. And we said that the root right there is going to be the denominator. All right, so it's pretty simple. We have the base number 10. So we just write a 10. And the exponent is the numerator, so that's to the power of 3. And the root is the denominator. So that goes right there, and that's it. Easy. 10 to the power of 3/2. All right, try number 11, please, and I'll give you a hint. When there's no exponent, you can automatically just make it a 1. So see if you can finish number 11. All right, so again, we said the exponent is the numerator, and we said the root is the denominator. So that is going to be 2. We keep the 2, and the numerator is 1, and the denominator is 3. 2 to the 1/3. That's it. All right, try number 10, please. All right, pretty simple. The exponent is going to be in the numerator, and the root is going to be in the denominator. So we keep the 5, and the numerator for the fraction is 5, and the denominator for the fraction is 4. That's it. All right, next section, we're back to the same instructions at the beginning. Write each expression in radical form. So it's going to be like this once again, just like the first section, but you want to make sure you have no negatives. Okay, so the exponent can't be negative and the root can't be negative. All right, so one thing you want to remember for the negative exponents, all right, let's say you have x to the power of negative a over b. Well, what you can do, you can make this into a fraction just by putting it over 1. That changes nothing. And basically, if you take this whole thing right here and move it into the denominator, it changes the plus-minus sign on the exponent. All right, so if you took this whole thing right here, you would have just a 1 left in the numerator. Okay, just if you're thinking, well, where did the 1 come from? Well, you can multiply anything by 1, right? If this is x, you can say it's the same as 1 times x. That's the same thing. All right, so if you take this whole thing and move it into the numerator, it changes the plus-minus sign on the exponent. All right, so we have a 1 in the numerator and move this whole thing down to the denominator, and now instead of negative a over b, it's going to be positive a over b. All right, so that's how we're going to get rid of any negative exponents. All right. All right, number 13, we have a negative exponent here. So we can multiply this whole thing times 1. All right, that doesn't do anything. And what I'm going to do we can put this whole thing over 1. Okay, what I'm going to do is take this whole thing right here, and I am going to move it to the denominator. Okay, and what that does is changes the plus minus sign on the exponent. So we have a 1 left in the numerator, and we have the 5x in parentheses. Close the parentheses, and the exponent, instead of negative 5/4, it is now positive 5/4. Okay, let me fix this because this is an exponent, not times 5/4. Let me fix that a little bit. All right, that's 1 over 5x to the power of 5/4. All right, and just like before, we said that the numerator is going to be the exponent, and we said the denominator is going to be the root. All right, so we're almost done here. We have a 1 in the numerator, and we have the 5x. Okay, see the parentheses around the 5x, so the entire 5x has a radical symbol. Okay, the root is 4. The root goes right outside. And the exponent is 5. So you draw the parentheses, and that is to the 5th power. So that's the form they want it in. Final answer. All right, why don't you pause and try number 15. And it's actually less work because you don't have to make the exponent positive. It's already positive. So see if you can do 15. All right, so we said the numerator is going to be your exponent, and your denominator is going to be your root. All right, so pretty simple. We have 10n inside parentheses, so now we're going to do 10n underneath the radical symbol. All right, the root is just 2, and the exponent is 3. Now, remember we said at the beginning when it's root 2, you don't need the 2. It's just radical 10n. And that's to the power of 3. That's it. All right. So little extra step there I just wanted to show you. It seems like unnecessary, but I wanted to show you that. All right, please try number 14. Okay, 14, we said you can just put the 1 out front, if that helps you, and make it 1 times this. And you can put a 1 in the denominator. Okay, neither of those change the value, because times 1 divided by 1, that does nothing. All right, so we said you can take this whole thing and move it down into the denominator, and it changes the exponent. Okay, so we have a 1 in the numerator, and 5x to the negative 1/2 is now on the bottom. That's going to be 5x inside parentheses. Instead of negative 1/2, it is now positive 1/2. All right. And we said the numerator is the exponent. And we said the denominator is the root. All right. So let's see. We have the 1 in the numerator. The 5x is in parentheses, so now that is going underneath the radical symbol, 5x. All right, the root is 2, and the exponent is 1, so this is raised to the 1st power. All right, now we said second root, you don't need the 2, it's just square root, and 1st power, you don't need that either. So it's going to be 1 over radical 5x. All right, let me fix that a little bit. It's just 1 over radical 5x. And that is because second root, you don't need the number. First power, you don't need the exponent. That's it right there, 1 over radical 5x. Number 17, I'll give you a quick hint. Instead of 1.5 as the exponent, you can change that to a fraction. 1.5 is the same as 3/2, and then go from there. All right, next section, we're going to exponential form once again. All right, so exponential form is in this form, x to the power of a over b, but now negatives are okay. And that is for the exponent. I should say negative exponent's okay. Let me fix that. All right, so negative exponents are okay, but we want it in the simplest exponential form. So it's going to be in this form, but the exponent might be maybe a negative. All right, number 19. So we said the exponent is going to be in the numerator. And we said the root is going to be in the denominator. Okay, so the base number underneath the radical symbol, that's just m. So we keep the m. And for the fractional exponent, the numerator is 3. And the denominator is 4. Easy. All right, try number 21, please, and I'll give you a hint. The v is raised to the power of 1. All right, so pretty simple. We said the exponent is the numerator, and we said the root is the denominator. So we have underneath the square root, we have the v. The numerator on the exponent is 1, and the denominator on the exponent is 4, v to the 1/4. All right, so quick hint on number 24. I'll start you off. We're going to take this whole thing. We're going to take this whole thing right here and move it into the numerator. Okay, and that's going to change the plus minus sign on the exponent. So this is going to be, you can keep the 1 if you want, it does nothing. 1 times radical. Underneath the radical, we have 3k. And that's in the parentheses. And now instead of positive 5, it's going to be negative 5. Okay, remember when you shift the whole thing up or down, you change the plus minus sign on the exponent. And when there's no root underneath the radical, it's automatically a 2. All right, so I'll let you finish this one from here. You don't need the 1. And remember, the exponent is going to be your numerator. And remember, the root is going to be your denominator. So put the parentheses around the 3k and apply the root and exponent. All right, here they want us to simplify. So hopefully we're getting a number. We might end up with a radical symbol, but let's see. Simplify, 9 to the 1/2. All right, well, this isn't bad. We said the numerator is the exponent, and we said the denominator is the root. All right, so we have 9, and 9 goes under the radical symbol. The root is 2, so it's a square root, and that's raised to the power of 1. So that's easy. All right. We know that the square root of 9 is just 3. Because 3 times 3 is 9. And if you raise that to the power of 1, that does nothing. 3 to the first power is just 3. Final answer. Like we said a few problems ago, when it's to the power of 1/2, it's just square root. So really, all this is the square root of 9, which we know to be 3. All right, let's look at 27. How many zeros do we have? Well, we'll do that in a minute. All right, 27. Actually, I still need to count the zeros anyway. All right, so I'm going to put this big number underneath a radical. Okay, and I have 1, 2, 3, 4, 5, 6 zeros. All right, 1, 2, 3, 4, 5, 6 zeros. Okay, remember the numerator is the exponent and the root, the denominator is the root. So this is the 6th root of 1 million, and that is raised to the first power. Okay, but the first power doesn't do anything. So if you think about it, they're asking, well, let me see, when you have a square root, you're asking what multiplied 2 times will give you 9, and that's 3, because 3 times 3 is 9. All right, and that's when it's a square root. The number is multiplied 2 times. So in this case here, they're asking what number multiplied 6 times will give you 1,000,000. Well, I know that if you take the number 10 and multiply it 6 times, you're going to have 6 zeros. So this right here, all right, we can ignore the first power. That does nothing. But this right here is the same as the 6th root, and this is 10 multiplied 6 times. So it's actually the same as 10 times 10 times 10 times 10 times 10 times 10. All right. And since this is the 6th root and we have 6 tens here, we can cancel 6 tens. 1, 2, 3, 4, 5, 6, and move it outside of the radical symbol. All right, just like when we did square root, you can cancel 2 of the same number, but now this is the 6th root, we cancel 6 of the same number. All right, so this whole thing is eliminated, and we're just left with the 10. So that's basically it. All right. An alternative way to write it, if you didn't want to write 6 tens, and I'll do it in a different color. If you wanted to, you could have written the 6th root of 10 to the 6th power. Okay? And that is because 1,000,000 is the same as 10 to the 6th power. All right? And then if you took this apart, you would have the 10. And remember, the exponent is the numerator and the root is the denominator. So the exponent on the 10 would just be 6 over 6. And we know that 6 over 6 is just 1, and 10 to the first power is just 10. So there's basically two ways. There's basically 2 ways to look at that problem. All right, let's look at 31. We have a negative exponent here. So what I'm going to do is make this 1 times this. It changes nothing, and I can put it over 1. That also changes nothing. But I'm going to take this whole thing, and I'm going to move it into the denominator. All right, so we have a 1 in the numerator. And 64n to the 12th is going to be raised to the power, instead of negative 1/6, It's going to be positive 1/6. All right, and now we could do one of two things. I'm going to try to make it simple, so I am going to distribute this 1/6. Okay, these numbers are multiplied by each other. All right, so we have a numerator of 1, and the 1/6 can go to the 64, so that's going to be 64 to the 1/6. And let's see, we have n. And remember, when you have something with an exponent raised to an exponent, they get multiplied, right? Like if you have, I'll write it off on the side here. If you have x to the power of a and you raise that to the power of b, that's the same as x to the a times b. So this n is going to be the same as 12 n to the power of 12 times 1/6. All right. So let's see. 12 times 1/6 is going to be 12 over 6. But we know 12 over 6 is just 2. So that's going to be n squared, and this is 64 to the 1/6. So let's see what we could do here. We have a 1 in the numerator, and we have 64 to the 1/6. So the 6 is going to be the root, and the 1 is going to be the exponent. Okay, and that's applied to the number 64. We have a 1 in the numerator. The 64 is in the denominator. And it's going to be the 6th root of 64. And that is raised to the power of 1, but really the 1 does nothing. All right, we also have n squared in the denominator. So this is times n squared. So this is, we can ignore the 1, that does nothing, but what multiplied 6 times will give us 64? Let's see. We keep the 1 in the numerator, and I'm going to put the radical symbol with the 6 outside. And 64 is actually the same as 2 times 2 times 2 times 2 times 2 times 2. 6 times. Okay, and that whole thing is still times n squared. All right, but the n squared is not under the radical. So basically, this is asking what multiplied 6 times will give us 64. Well, that's just 2. We have 6 2s, 1, 2, 3, 4, 5, 6. We can bring that outside. So it's going to be 1 over 2 times n squared. Final answer. All right, I'll start you off on number 26, and then that'll be it. All right, we have 343. We have a negative 4/3 exponent. So I'm going to change that to a positive. So this, we can make this times 1, and we can make it over 1. That's the same thing. Okay, I'm going to take this whole mess and move it down. And that's going to change the plus minus sign on the exponent. So it's going to be 1 divided by 343. And instead of negative 4/3, it is now positive 4/3. All right, and we said the numerator is the exponent. And we said the denominator is the root. All right, so we still have a 1 in the numerator. And the 343 is going to be underneath the radical symbol. All right, the root is 3, so that's outside. And then the exponent is 4. All right, so I'll let you finish that. I'll give you a hint. You want to find out what multiplied 3 times will give you 343. Once you get that answer, whatever number you get here, you raise that to the power of 4. And you should have a number at the end with no exponents. But of course, it's going to be a fraction. It's going to be 1 over some number.